Hello and welcome everyone to today's webinar. My name is Todd Carlson. I'm going to be moderating this webinar. If you have any questions during it, on the right side there's a chat or ask a question, and I'll be looking at those, answering those, and asking Jim throughout to answer any of those questions. So feel free to chime in there. And I'm joined today by my Uncle Jim Carlson, who's our regional manager in the Mid-Atlantic region. And take it away, Jim.
Okay, thanks, Todd. All right, this presentation of Carlson Point Cloud will be shown using files from, as you can see on the screen here, SenseFly eBee mapping drone. And what we've discovered is that this drone device is very simple to operate and allows you to essentially map aerially a site very quickly and register the cloud and the ortho photos into a UTM zone or a NAID 83 zone. And I wanted to go into this point cloud presentation and show how point cloud works with these SenseFly eBee mapping clouds and TIFF files. The presentation will be in 4 parts. Part 1, I'm going to just discuss the point cloud basics 101. This isn't going to be a high-level training on point cloud, but I will talk about the basics and how the program operates for those that have not used the program. Part 2, I will demonstrate how point cloud works with a SenseFly eBee mapping cloud using an example called Donan 2. And part 3, I was going to show how to do a contour and a stockpile map with contours and do volumes with stockpiles essentially. And the last part will be Pete Orvovich of Caranese. Caranese actually has the distributorship for selling the SenseFly eBee drones in 45 U.S. states and internationally, and can sell internationally. So Pete's going to discuss the last 15 minutes how the SenseFly eBee mapping drone operates and their office software. Okay, part 1, Point Cloud Basics 101. What is Carlson Point Cloud and how does it work? As you can see, when you load the Point Cloud menu, there's only 2 menus, and there's one drop-down, Point Clouds, which I have right up there on the screen. And we have Point Cloud Setup, which we have displayed right here. And there's 3 cloud engines that we use. We are right now experimenting with Carlson and 3D TK and trying to expand using different cloud engines. But the primary cloud engine that we use right now is called Point Tools. And Point Tools is a company, I think it was originally from UK, and in the 4th quarter of 2011, Bentley purchased Point Tools, and we now pay royalties to Bentley when we sell Carlson Point Cloud or the cloud engine, which you'll see shortly. Carlson Point Cloud works standalone and reads and writes to Carlson Civil Suite. That's our office software working in AutoCAD or IntelliCAD. The read and write functions work with CAD, AutoCAD, IntelliCAD, CAD entities, and obviously with Carlson native files, which I have listed here: coordinate files, CRD, our profiles, cross-sections, TIN, grid for modeling, and center lines, and PLN files. We pretty much use the CL and the PLN files to import from the AutoCAD CAD drawing into Point Tools. So those are the 3 types. We can only handle about 20 megabyte of points with Type 1 and Type 3, and Type 2, the Point Tools engine, can, depending on the memory of your computer, can handle 1 gigabyte to 2 gigabyte of points. All right, I want to discuss must-know top 10 major features in Carlson Point Cloud. And I'll just go through them very quickly. One, import export, which I will be doing, common point cloud file types. The default standard type that we work with in Point Tools is a pod file, a file named .pod. You can also read in LiDAR, asterisk LAS files, Pointscape PTS files, Faro files, Leica files, Regal, Topcon, Terrascan, and also we can do generic files and the like. We have Carlson Point Cloud menu tabs, which I will show shortly, project, scene, camera, action, and data tabs. When I bring in point clouds, I very often, to work with them, I like to put it in there, slice and dice the point clouds for easy review and output. If I want to focus just on one specific area, I use resample quite a bit, clean. Transform allows you to transform the coordinates to maybe state plane if you get a scan that's not in state plane. And for viewing the point cloud files, once you bring in the point cloud, that is either importing it or loading a pod file, you create scenes or views to display the point cloud files and we have 3 different modes: simple, position, and color mode. Once you have it in there, you can pan, zoom, and or set your camera origin for fast 3D viewing and data extraction in the cloud. The last item here, 5 of the top 10, Action tab, this is where all the action occurs. This is where you actually create entities, points, and the like inside the point cloud for extraction to send to CAD to do the finished plat. So the Action tab outputs Carlson points and CAD entities. Carlson coordinate files, 2D, 3D polylines, 3D pieces, contours, profiles, cross-sections, Carlson models, tin and grid files, mapping and volume compute applications. So
you just think so screwed up trying to get out on the net.
Well, that phone call was just,
I actually have Pete from Karen East on the phone. Todd, could you mute Pete?
Yeah, I just did.
Thanks. Alrighty. All right, so let's first bring up the menu here. And all right, first of all, here is AutoCAD. And as I said, it runs, Point Tools runs separately. I'll show you how I loaded Point Tools right here. But I just wanted to bring up a scene very quickly. You can see the red dot in the screen right there. And if I use the mouse, I can zoom up and I can see the point cloud. It almost looks like a photograph. And I can hit the pan button. I can pan around and just pretty much do that. I can see there's buildings there and the like. And I'll be attempting in part 3 to do a little volume job with this. And I'll close that. Here, let me close that and close this, close that. And let me bring up another job. This job, you can see that I have brought up a raster image of the site. And what I want to do is continue drawing some lines here in the point cloud for these paint strips for parking and maybe this island right here or this island right there. So to bring up point cloud, I go to the point cloud manager and I'm going to do open. And load up a PC file, which is a point cloud extension for Point Tools. And this brings up the job. And I just want to show you that we have some clouds that I've brought in. This is the full cloud. Let me go over here and come down and just do properties and show you that this cloud that I brought in has 53 million points. If I want to come up here and just draw another line along here, in the cloud, I'm going to go down to the scene here and pick view. And now I'm actually in the point cloud. And I have created points and drawn lines between those areas right there. What I would like to do is continue and make additional polylines. I'm up to the 7 polylines now, so I'm going to go to Action here. And I'm going to do this by picking points and creating polylines using our field to finish that's from Carlson survey that's embedded in Carlson Point Cloud. So I pick point here, and I want to select a code. So I go to code, and the code table that's loaded is carlson.fld. I can pick another code table if I so want to. I'm going to go to road features here and just pick I. And that is the code that I'm going to draw. And I'll just create I8 for the line work. And it says start a line right there. And I'm going to come up here. Now, you can see the red dot. That's where I'm going to pick. So if I want to window up and snap to, let's say, that dot right there, I snap to it, come over here, and snap to that dot right there. And that created that one line. If I do end line, and I like to code my lines with the code and a number afterwards, so I'm going to create a new code right now. And I'll just come up here, hit the control key down, come over here and pick this guy here, and end a line there. And we'll just do one more. Well, actually, I'm going to change the code to edge of pavement. And we're going to arrow key out. And I'm not going to go crazy, but I'll just draw the edge of pavement on this line right here. And all right, hit the control key down, hit a point there. And I'm going to do undo. And I'll call this EP9, so I have a different line going. And if I window out a little bit, I can see the where the edge of pavement is, the dots. And this is pretty much how you manually virtual survey a job site after the fact. Belabor the point, but that is manual drafting, but you're drawing and actually picking dots that have an X, Y, Z. So I'm going to do end mode now, or end align, end mode, and if I go over here and I just want to plot this last one here and do draw, I can draw one, or I can come up to here and I can do draw all. But I'm just going to draw them individually. I think I just drew 3. Okay, we'll save what I've done so far, close this out, and I'll close out point cloud. And there you can see 2 white lines appeared right there. If I do change, I think I have them in layer 0. I'll just put them, here it says change, enter, P for properties, color, and D5. Okay, and you can see that I just added 2 lines on the geo-reference TIFF file, and you can see over here I have my polyline that I drew right here. And if I list this guy, you can see that it came across with elevations, escape, and that's pretty much how, we'll go back to the PowerPoint presentation, how the Action tab works, where you can actually pick nodes or dots in the point cloud individually and draw points and or line work. Continuing on, Action tab, field to finish, F to F coding. I showed you that, where you can load up a field to finish code table in Carlson Point Cloud and draw using different codes and create points in the drawing. And The Data tab is next, studying the point cloud, coordinate, intensity, color, X, Y, Z, I, RGB, red, green, and blue. Every one of the dots that come in have an X, Y, and a Z, an intensity if the file comes across with intensity, and if it's in color, which this job is in, it comes in with different hues of red, green, and blue for each dot. The Project tab is where you collect all the data, that's the polylines, the CAD entities, and the Carlson default file formats. And down here we have Carlson point cloud settings. You can also set up the background so it's not in a black background. It's similar to AutoCAD's options command, where you can change the background and some of the settings inside of point tools. And the last option is plot all DWG output to AutoCAD or IntelliCAD. Carlson Point Cloud 2014 will export to either AutoCAD 2004 up to 2014 or Carlson's IntelliCAD 7.2. And of course, as mentioned before, Point Tools reads and writes CAD entities from the cloud or from AutoCAD or from the DWG back to the cloud. And both Point Tools and Carlson Civil Suite work natively with the same file formats. SenseFly eBee Mapping Advantage. The one thing that we've noticed at Carlson, working with the SenseFly eBee drone point cloud maps and geo-reference tip maps, are that you get a collection of files. And you get a LiDAR file, which I'm going to bring one in from scratch and show you on the next example of doing volumes. You can bring in a LiDAR file, import it, create the Carlson pod file. You can also, in CAD, load the OrthoMosaic geo-reference tip file. And what's nice is they have a quality report, PDF report, which tells you what zone, either NATE 83 or UTM zone they're working in. And it also tells you what the average distance is of the point cloud that's being delivered by the SenseFly software. In this case, it's about 3.5 centimeters. And they also throw out a rough CAD package, CAD DXF file. But as you'll see when I finish making the contour map and doing volumes for the next example, stockpile example, that the output looks a lot better inside of Carlson Civil Suite. Okay, the eBee point cloud and Ortho tip map are both geo-referenced, so you're working on the same coordinate system. That's very handy. SenseFly eBee point cloud consists of millions of points when surveying out the field. And with that drone device, you can map daily, weather permitting, and at your convenience, virtual survey in Carlson Point Cloud anytime later. So that's a real handy capability of working with these maps produced by SenseFly. Okay, I'm going to start part 3 now, which is the point cloud to stockpile volumes example. Notice that right below there I said decimate, decimate, and decimate. That is because I discovered that to get fast and quick results for both contouring and volumes, you really want to decimate that point cloud. You don't need to work with all 23 million points if you get virtually the same earthwork and contour results from the decimated file. So I'm going to go through these 5 steps inside of Carlson Point Cloud first, import the LiDAR, decimate it in Point Cloud, then I'm going to create a mesh, and then I'm going to export it to Carlson Civil Suite from Point Cloud, and then save the Point Cloud project. So I'll do that from scratch. Okay, right now we're going to load up, I don't have Point Clouds loaded, so I'm going to come down to Point Clouds Manager. I'm going to load up this example, and I've already created the mesh file, but let's actually do this from scratch. Shouldn't take that long. So I'm going to do new, and we'll just call this STK-2. And right now I have nothing in the project. So I go to the Clouds menu item, and I select it, and instead of doing add, where I add like an existing pod file that was already created, I'm going to come down to import and import a LiDAR file. There's the file. I pick it. It's 40 meg in size. And now it's importing that LiDAR LAS file. This only takes a few seconds. And as soon as you see, there it is. And it's created, imported in that file. Now that was a 40 meg file. Let's go down to properties and see how many points are in the cloud. And this is a fairly good example of a eBee map created by SenseFly. And there's 23 million points. Position is on, color is on. I'm going to pick OK. And I want to create a view. You can see there's no scenes. The only file that I've created so far is piles. I'm going to come down to do view. And there's 3 types of cloud viewing you can do. If you do simple, it's just white dots, no color. If you do position, Carlson point cloud will color the point cloud by elevation. And if you do 3, it will bring in the point cloud with the elevation stored in the point cloud's RGB. There is the point cloud. It won't take too long to come in. And you can see that as I move this up, whenever you're moving, be very careful that the blue z-axis is pointing up. If you go the opposite way, you sometimes think you're actually looking at the site, but the blue is looking down. You're looking from underneath. So I'm going to move this back up again. And if you ever want to get back to where you were before, you can store a home position, or you can just do zoom front, zoom center, and zoom extents. And now I'm going to move this. You can see the blue key. And if you move your cursor where I have an XY down here, you'll see a Z that allows you to turn it. And the red dot is the center position of the map. If you do want to change the center position, you can go to camera here, go down to custom, and just pick this little dot here. And with the control key down, it says control click. I'm going to pick the beginning of this Hall Road. There, the red dots changed there. Now, when I rotate it, it's not the center of the job anymore. It's rotating around that red dot right there. So that's a handy way of changing the aspect. You can also come up here and change the view right there and do all that. Now, at this point, I'm going to cancel this and go back to project. What I want to do is decimate inside of Carlson Point Cloud this file. So I'm going to pick this and come down and do resample. And I'm going to set it to 250, resample every 250 points. And you can see I've created a file there. If I come down to properties, you can see we have less than 100,000 points. And that's still an amazing amount of points. You'll see when I bring it into Carlson Civil Suite. Let's actually make a TIN file using the create mesh command here. And it's going to create this right here. And I'll just pick OK. And it just created a mesh from scratch. And there it is. And if I come down and I do export, this will export it to, and I'll just call this STK-2 to create a new grid file. And at this point, that's my project file. Go back here, and I'll just call this STK2. Open and save it. And that created a Carlson TIN file that I exported from Point Cloud. Let me go ahead, save this, and close. Now, what I want to do is go to the Civil Suite and go ahead and plot that T-mesh. I want to show you how busy it is still. And I'm going to pick, there it is. And that's the layer I'll put it in. I have no inclusion perimeter. I actually do have an inclusion perimeter. I've drawn up, to help me with this presentation, I've drawn up some polylines that I don't want to waste time drawing that I do need. And I have pile perimeter, and right there. And this is the one I want to draw. There's my perimeter that I want to draw the mesh with. So I come up here, and I'm going to pick my stockpile, pick the inclusion perimeter. Exclusion perimeters, I'm just going to hit return. And you can see that you have a lot of detail right there. And now I'm just going to go up to contour and pick right here. And I have write a tin file, and I'm going to call this STK2DEC for decimate. And how am I going to decimate this? In Carlson Civil Suite, we have a simplify surface elevation method. And I'm also going to contour the results as 1 foot contours, 5 foot intermediate, and label in just the intermediate index contours. So I am writing a tin file. I am going to be using an inclusion-exclusion perimeter. So I pick OK, and I'm just going to pick right about there by crossing. It grabs the one closed polyline, hit return, no exclusion perimeters, and now I'm going to grab this tin here. And we are done with creating a contour map. And those contours look pretty accurate to me. Now I'm going to delete the this excessive tin. That's after being decimated to 100,000 points. I'm going to do that again, L-del. I'm just going to pick this guy here. Let me just grab that guy there. And okay, and I guess I have some of the labeling messed up. I apologize. Okay, and what I want to point out is that there's a contour map completed for this site, and I am ready to do volumes next. The let's actually bring in the ortho photo for this site. Place image file. This is coming from the Sensfly software. And of course, I have to send it to back. There you go. You have that contour map created from the point cloud, decimated inside of Carlson point cloud, then brought over into Carlson, and then we redecimated it to essentially be able to contour it so that we created these contours very quickly. And the last thing I want to do is just create a stockpile volume for this area right there. And I'm going to do that in the Civil Suite package, come up to Surface, come down to Stockpile, calculate stockpile volumes, hit return, and we'll just select this one here. I've drawn those inclusion perimeters and that polyline perimeter ahead of time, pick OK, and there's the volume, 407 cubic yards. And we can set this right there. And if I want to do another one, I can come down here and just grab them as fast as I can snap to them. After picking the inclusion perimeter, that's the stockpile area. Set this one to the screen. And there's the pretty much the end product both contoured and volumes calculated fairly quickly directly from that point cloud. And I'll go ahead and save that. Let's go back to the PowerPoint. And so I completed those steps right there inside of Carlson Point Cloud. And then in the Civil Suite, you saw that I plotted the ortho georeference TIFF file that came from SenseFly software. And then next step in the Civil module, I triangulated and contoured the drawn triangular mesh. I then decimated that mesh yet again and removed all tins that were essentially flat or at the same slope, so that it created a contour map very quickly, and stored that as a new tin file. And then fixed areas with unwanted contours. I actually didn't do that. I had some exclusion areas I was going to demonstrate, but you can do that very quickly in Civil Suite. And then I drew the stockpile perimeter polylines. I did that in advance, just imported them as a PLN file. And then with windowing just each stockpile, I was able to do the last step, which was compute stockpile volumes in Carlson Civil. Okay, at this time, I'm ready to hand it over to Pete for him to show me the, or show us the SenseFly eBee information on his mapping drone.
Okay. Pete, I'll make you the presenter.
Presenter? Okay.
And you just say okay to that.
Yep. Okay. I'm ready when you are. Am I presenting now or what?
Yeah. You,
Show my screen.
yep.
Okay. I need to minimize this over here. How do I minimize this?
Jim, one question that came in as Pete's getting ready. Is the image that we were looking at point cloud created or from the eBee drone?
I have to
From
ask
the
exactly where, because the image, when I was in Carlson Point Cloud, that was the point cloud, and when I was in CAD, that ortho image, both of those were created by the eBee SenseFly software, georeferenced, and I was able to bring in the point cloud inside of Point Tools, and I was able to bring in the ortho TIFF file in the CAD package, and then able to draw whatever I drew, polylines, points, and so forth, from Point Tools into the CAD package on top of the ortho photo, which is extremely handy.
Okay.
Okay, Pete, it's all yours.
Okay. For all you who are not familiar with Karen East, we're our base office is in Cumberland, Maryland. We were founded in 1954. We offer a complete geospatial solution. We offer GPS, mobile scanning, static scanning, any type of survey equipment, machine control. We do it all. And now we have a new product that we'd like to tell you about, is the SenseFly eBee, the drone. So this SenseFly has two types of drones. They have the eBee, which is the one over here on the left, and the Swinglet, and both of them are able to fly and take pictures, do aerial survey. It's a new tool. You can do 2D and 3D maps at a low operational cost. All right, the typical the way to survey, you've got satellite imagery, which resolution is typically about 50 centimeters. And the delivery time, it takes weeks. Manned aircraft, again, for an aerial survey, delivery time is weeks to months, to 10 to 30 centimeters accuracy, resolution. And then you have terrestrial means, which delivery time, depending on, is on the qualified worker and availability. And then now we have the mini UAV, which flies below the clouds. We fly 400 feet and below. So here's our products. You choose your UAV, either an eBee or a swinglet. Okay, you conduct your mission, and then after the mission, you post-process the software. So you can actually go out and fly your mission and have your data by the end of the day. The eBee is very light, weighs less than 2 pounds. It's fully automatic on the flights with the eMotion 2 software. You're able to program your mission and your flight plan there, and it does not. This is the only drone on the market that does not require you to have a pilot's license to fly because of the weight, it being so light. And there is no launch system with this eBee. You launch it by hand, and it's very simple and easy to operate and to plan your mission. Okay, but right now what you're looking at is the swinglet, and the eBee is very similar as far as what's on board. You have a camera, you have a battery, you have your autopilot, and your autopilot includes your IMU for pitch, roll, and yaw, and then you have your onboard GPS for position. And you have your pitot probe, which is going to measure the barometric pressure and your airspeed. And you have your servo rods, you have your propeller that's in the back, and you have your airframe. And here's the difference between a comparison between solutions. I would suggest for the cost, I would personally own the eBee. They both have a 16 megapixel camera on board, and now even though this right here says there's not an infrared camera, there is an infrared camera that is available. The average speed is about 25 miles per hour and about 45 for the eBee, about 25 for the swinglet and 45 for the eBee. And the swinglet can handle about a 16 mile per hour wind and keep on course, where the eBee can handle up to about 27 miles per hour. Okay, they both have autopilot. The battery life for the swinglet is about 30 minutes, and the battery life for the eBee is about 55 minutes. And that 55 minutes really equates to about 45 minutes of flight time. Your data link is with a 2.4 gigahertz radio, and you stay in constant communication with your drone. I mean, you can lose communication, but there are safeguards so that you won't lose your eBee, that will go and make an emergency landing. You have an optional manual controller, but it's not. We don't recommend that you use that. That you use the auto flight plan instead. Another difference between the swinglet and the eBee is the swinglet, it's fixed to the body, and the eBee are detachable. And if you break a wing on the swinglet or something, it breaks off, you've got to replace the whole body, and it's going to be a lot more expensive. Where with the swinglet, with the eBee, you have the detachable wings, and a pair of wings. The cost on that's about $380. So it's pretty inexpensive if you have a problem to replace those wings with the eBee, rather than have to buy a whole new body. The processing software you have to purchase separately with the swinglet, and the eBee, for each eBee, the license is included, and it's included for that particular eBee. So when you purchase the eBee, you don't get a license for the software to be able to process for other planes. You can only use it for that particular eBee, for that serial number of it. And then the size of the transport box, the swinglet, it would be luggage if you were taking it on board and traveling with it. It'd have to be considered as luggage, where the eBee, it packs up in a nice little tight little case that you could actually hand carry it onto the airplane. And then the landing method with the swinglet, you only have a circular landing method, and with the eBee, which is preferred, you have a linear landing that you can do with it. And what's nice about the eBee, it'll come in at about a 20-degree landing angle, and so you're able to survey in a very tight area. If you have a lot of obstructions around, you can bring that eBee in at about a 20-degree angle, and you just need about a 40-yard clearance radius around the area you want the eBee to land. So advantages to our very light UAVs. Basically here you're just seeing the kinetic energy that it takes to drive a golf ball, to kick a soccer ball, and for the other UAVs, you can see it's a lot greater. But for the eBee, it's only about you have 70 kinetic energy J. So now we come to the flight planning and monitoring with the eMotion 2. That, as you can see here, what you're looking at is when you go out in the field with your eBee and you hook up, you can have preloaded maps and a coordinate for the area that you want, or you can use your Wi-Fi on your computer and have a MiFi device and hook in and download a satellite imagery and center on the eBee, and your map will come up. Excuse me, didn't mean to do that. But anyways, your map will come up, and your eBee will show. You'll see your eBee, the map actually centered on the eBee. Okay, and then once you do that, you want to pick what's your ground resolution. We recommend about 3 centimeters, and then you have your image overlap, which that can vary depending on how accurately you want to survey the area. You can put that image overlap to 80, 90% if you so desire, but we recommend 70. And once you put in this information, you also tell it, okay, the working radius that you want to work in. The eBee will remain in contact up to almost 2 miles, about 1.5 miles, 1.75 miles with the radio system you have. So I wouldn't think you'd want it to go outside of that area. But you can pick that radius in the software. You also pick a ceiling, and with the FAA regulations, you got to keep the eBee under 400 feet. 400 feet or under. So we typically choose about 130 meters as our height, maximum height. And then next, once you've set those parameters, the software, and what you're looking at here is you're seeing the flight pattern of the eBee. Once you've picked your overlap, your resolution, the eBee then will plot all the waypoints, and it will take pictures along this route, and that's the route your flight plan that the eBee is going to follow. So the mission is automatically planned, and you can also do perpendicular flight patterns. You can tell it, say you're doing a building, or you've got a lot of buildings, you want to get the side walls of them. You can also have the eBee not only fly in one direction, but you can have it fly in the other direction too. So once the mission is planned and you have your everything in there, you upload it to the eBee, and then you go fly. And you simply, the eBee, once you've you loaded up the flight plan, you hold the eBee with the 2 wings with your hands in front, and you hold the eBee at a level position. You shake it back and forth 3 times. That will start the engine. The pitot, there's a little thing, it'll turn blue, and then it'll start blinking green. When it starts blinking green, that means the engine RPMs have cranked up. You tilt it at about a 10-degree angle, and the eBee then, the pitot on the eBee will turn green saying it's ready for flight, and then you just take a step forward and just thrust your hands forward and release the eBee, and it's off and flying. And it'll then fly the mission. There are safeguards in there. If the battery gets low, it'll. One thing I failed to mention, when you're doing your pre-flight planning, you're picking a starting point and you're picking a home point, and your home point is where you want it to land. So when it's in flight, at any time you can tell it, hey, to come home, to land immediately. If it loses its GPS, it will land. It can't get back to the home point, but it'll start doing a circular landing and land. If there's too much wind, it'll come back to the home point and land. If the battery gets low, it'll come back to the home point and land. So it has a lot of safeguards built into it. So it's your chances of losing your eBee are very, very slim. And then step 4 is your flight monitoring. You're gonna be watching your computer, and you'll be seeing the eBee fly its patterns, and if you get any error messages, you can respond to them. So you can also alter your flight plan in flight. And if it doesn't have enough battery to finish the flight, it'll come back, land, you can quickly change the battery, send it back on its way, and it will resume its flight and go back to the last waypoint that it recorded a picture at and start the survey from there. So, the eBee comes with two batteries. That gives you 90 minutes of survey. If you so desire, you can purchase extra batteries, extra wings. Anyway, some of the safety features in our UAVs: pre-flight automatic test procedures. Like I said, once you plug in the battery, you've got to set the eBee at a level position on the ground, and it'll go through a calibration check. It'll do a GPS signal check, a battery level test, and a configuration of the home point, and a sensory calibration test. And then in-flight safety actions, it'll go to the home point, it'll do an emergency landing, it'll hold and resume for air traffic management, and you can restart the propeller. So, management of critical situations down here. If there's a barometer error, it'll go home and land. The eBee has a ground sensor on the bottom of it, so it can sense when it's coming up to the ground. Way out of the working area, strong winds, it'll make an emergency landing. Wind too strong, it'll go home. Low battery, go home. Empty battery, emergency landing procedure. It's going to land immediately. IMU error. So if there's a problem with the IMU, it'll make an emergency landing procedure. And then loss of GPS signal. Again, it'll do an emergency landing procedure. It's not going to go to the home point in those circumstances. Now, current applications. You can as you saw on that demo that Jim did, that was a rock quarry that we flew, and you can do volumes. You can do pictures of landscape, buildings, crops, forests. Forestry guys are very interested in this. Agriculture, farms for farm management. The 2D and 3D mapping, the pictures processing allowed to create a geo-reference orthomosaic. So it'll take all those pictures that it took and sew them together and give you an orthomosaic. It'll give you a digital elevation model, and it'll also do it with an accuracy of about 5 to 10 centimeters. Let's see, applications are mining industry, agriculture, GIS industry, construction services. You got your orthomosaic, which is a TIFF. You got your Google Map tiles. which are PNG, KML, your digital elevation model, which is a TIFF or text, your point cloud, which it doesn't say down here, but you also can generate an LAS file. You just tell it in the post-processing software. And your triangle model is an OBJ, excuse me. And then your auto imaging process, you'll have all your images, and then the post-processing software will create the ortho mosaic. And will also generate the DEM, the digital elevation model. So your benefits, you can measure, you can export, you can do cut, fill, volumes, areas, distance. One of our colleagues, Chris Robson, they did a soccer field, and they measured this soccer field within a tenth of the actual measurement. So that's pretty good. So operational cost, the eBee is about $26,000. And it's a turnkey price. That's everything, with about a half a day of training involved. You know the cost of your survey equipment, and you know the cost of what it costs for aerial surveys. So the eBee, you own it, you can fly it at any time. If it typically takes about 20 to 30 minutes to fly a mission. So if you have to go back and resurvey something, you can do it, and you can your processed data you can have by the end of the day. So it's really quick. Your initial cost is a little high, but not for what you're getting.
That one this morning, approximately 15 acres.
Yeah, what was it, 15 acres? Yeah, we did one this morning. It was 15 acres, and it took us 20 minutes to actually fly it. We're going to process the data this afternoon. Okay, regulatory framework in the USA. Right now, it's for non-commercial purposes. You can use it for 400 feet. You can do it for your own internal surveys, but you can't take the ortho mosaic right now and sell it to somebody else. Now, if you're a government, state, local, federal, they can use it. But 2015 is when they're going to open it up. The UAVs will be allowed for commercial applications. So. And that's the end of my presentation. What I'm going to do now is if you have any questions, you can go to our website, which is www.quroneast.com. We have movies there, eBee in flight, and any other information that you would like about anything that we sell. So hit escape. I was going to play a little movie for them. Okay. Hold on. I was going to, if you want here. Do we have time for this?
Yes, do it, Pete.
Yeah, and we had some questions that came in the chat.
Okay. And what this is being flown in the Alps. And you'll see this guy will come up on skis with the eBee, unpack it, put it together, plan the mission, fly it, put it back in its case, and ski off. It's pretty cool. So here we go.
Is there sound on it, Pete?
Yeah, well, there is sound, but he's got it muted. That's fine. Todd, what are the questions? Well, everybody can watch this movie. I've seen it 2 or 3 times. It just shows everybody the ease of use. This product is fairly foolproof for getting quick and accurate point clouds and georeference TIFF files. What are the questions?
Yeah. Some questions are with the FAA stuff. I guess you kind of answered that it's for non-commercial use, but you can use it to collect the data yourself. Is there any formal permissions you need to get one of these?
There.
Pete, did you hear that question?
What's that? I can't hear because of I can barely hear you guys talking.
Okay. The question was, what kind of permissions do you need from the FAA?
I still didn't hear you. This is almost finished. Just ask me.
Okay. Jim, do you know how many square miles the eBee covers in one charge?
Well, it can run for...
In one flight, how many square miles?
It could run for
well,
about...
we did, what, 15 acres in 20 minutes. Yeah. Yeah. Yeah, hold on a second. I'll address it when we're done. I should have. Okay. What was the question again? Sorry.
Yeah, a couple questions. How many square miles can the eBee cover on one charge?
I'm not sure, but I'll have to look. I just tell you you know, you got a 45-minute flight. We did about 15 acres in about 20 minutes. The thing is, if in a single flight it doesn't complete its mission, it'll come back and land. You change the battery, and you send the thing back on its way. It'll complete its mission. It'll go to the last waypoint that it recorded a shot at it, that it actually took a picture, and then start the mission again from there. So you can cover a pretty good area. I'm not quite sure exactly what the square mile area would be. So,
Hey, Todd, could you send the focus back to me? And
Sure. Yeah, I had a couple more questions for Pete. Does the software have the ability to remove vegetation like trees and grass from the
yeah, you can edit the photos before you process.
Okay. So the FAA restricts using it for commercial use. Is there any sort of permissions you need to get or approval to use one of these?
Well, okay, you can't fly within 3 miles of an airport without special permission. We actually flew, did a demo at the Langley Air Force Base, and we were just in constant contact with the tower, letting them know when we took off and when we land.
Okay, but ownership and using it, you don't need any special permissions as long as you...
Yeah, as long as it's for private use. You're right, correct. You can fly it on private property, or if you have the permission of the landowner to fly it on, you can fly it. You can also, it's such a small airplane, it actually looks like a bird in the air. It's not going to be picked up on radar. I'm not trying to tell everybody to break the law, but what I'm trying to say is if it looks like a model airplane up in the air, it's so small. So.
Right. Okay. Yeah, that was it we had on questions.
But on that square mileage, if I have if I get the email addresses of everybody, I'll address that question and send it to them, because I don't know exactly the answer for that, so I apologize.
No problem.
well, Todd, it's 1 o'clock. This was a 1-hour presentation. I just wanted everybody to see that the eBee Sensfly mapping drone and software is a really good fit with Carlson Point Cloud that allows you to work with civil point clouds as opposed to mechanical and architectural indoor point clouds. This product that Karen East is selling is an ideal product to work with Carlson Point Cloud to do your fill-to-finish mapping and to do your contouring and volumes.
And you can use this for your internal use. You just can't sell like the orthomosaic. You can't sell the service. So if that makes sense to everybody.
Okay.
All right. Thanks for everyone for stopping by, and we'll have this posted on our website. And thanks, Jim and Pete, for your time.
Yep, no problem.
Thank
All
you.
right.